Okay, it's time to talk about parallel circuits. So, parallel resistances are just like series resistances, but with a few catches. So, parallel. Well, the first thing that in which they are different is that for the series resistances, we said that they had the same current and a different voltage. But for parallel, they're going to have the same voltage and a different current. So let's draw a circuit in parallel. I'm going to draw the exact same circuit with the exact same three resistances, but this time in parallel. So in parallel, we're going to have this power supply, which is a battery, a normal battery. And we're going to have the first resistance here, the second resistance here, and the third resistance here, all the way down here. There we go. So I'm just going to call this V just like before, and it's going to be 12 volt. R1 is still going to be 1 ohm, R2 is going to be 2 ohm, and R3 is going to be 3 ohm. Now, before we said that we were actually going to have three resistances, and in which the end side of the first one was going to be used as the input side of the following one, which was going to output something which was going to be used as an input by the third one, which was just going to output something else, and then all the way down to the battery. So having those three will be the same like having one next to the other next to the other. And we were actually able to say, okay, fair enough, this is going to be like having a big fat resistance here, which was going to be given by the sum of all those three resistances. So one plus the other plus the other. Now, in this case, we can do the same for this circuit in parallel, but the total resistance is not going to be given by the sum. It's going to be given by something else. So our total will be R1 in parallel with R2 in parallel with R3. So our total, let's just plug numbers back into those. So will be 1 in parallel with 2 in parallel with 3. Now, what does parallel line mean? Why are there? Well, they just mean the product over the sum. So we will be doing the product of 1 times 2 over the sum, 1 plus 2, everything in parallel with 3. So our total will just be 1 times 2, the product, over 1 plus 2, the sum. Product over the sum, everything in parallel with 3. So our total will just be 2 times 1, which is 2, over 2 plus 1, which is 3, or everything in parallel with 3. Now, as you know me, I don't actually like to keep fractions in circuit analysis. So I can write 2 over 3 as 0.66. And I can say, okay, I have 0.66 in parallel with 3. So our total will be 0.66 plus, times 3 over 0.66 plus 3. So the product over the sum. Now our total, 0.66 times 3 will be about 1.98, roughly. And 0.66 plus 3 will be 3.66. So now, if I grab my calculator and I divide those two, I'm gonna get 1.98 over 3.66, which is about 0.54 ohm. So 0.54 ohm. Now, if I just like before that we found the current, I can say, okay, so the current, if you remember the triangle, we have V, I, R. So I'm gonna find the current is V over R because of Ohm's first law. Very, very important. We're gonna use this several times. So I would just be, well, R total, I should really be writing R total as I said. So 12 volt over R total, which is 0.54. So 12 over 0.54 is 22.2. I'm just gonna write 22 amps. Just gonna write 22 amps. Now, this is something that you should pop in your head. And they should really pop up in your head because, you know, while we were doing this, I was really and intentionally comparing this same circuit with the one in series. And if you remember, for the one in series, we found out that the total resistance was 6 ohm and the flow of current was 2 amps. So 6 ohm is a reasonable resistance for 3 resistances in series, and 2 amps was a reasonable flow of current going through the circuit. But here we have the exact same 3 resistances but in parallel, and we found out that the total resistance was way lower and the current was way higher. Why is that? Well, you can think about you can think about the current flowing as like cars going in a highway. So if you think about cars going in a highway and you think about the series, okay, you have just one, in a highway you have just one lane with all the cars going in this direction. And there are many cars. But eventually they get stuck in line. The one next to the other, but they're stuck in line. There is a queue and so on. Not many cars are gonna go through here. However, if you add another lane in the highway, the car can say, okay, there are many cars here, but I'm gonna go here. I'm gonna use this one. And if you add another one, cars can say, okay, I'm gonna go through here or through here or through here all at the same time. So as you can see, there are gonna be many more cars going through here than there would be if you had just one lane. So having just one lane is like saying we have resistances in series, but having, well, those 3 lanes will be just like having resistances in parallel. So the current is effectively just like cars going in a highway. They're gonna use the first lane and the second lane and the third lane at the same time. So effectively, many more cars, so many more charges, are gonna go through here at the same time because they can go through here and here and here at the same time. Now, for series, we said that they were actually going to have the same current and a different voltage. But for parallel, we said that they have the same voltage and a different current. So now that I have found the total current, 22 amps, I can verify this. So, okay, let's say, well, fair enough. Let's say that I know that this is true, so they have the same voltage and different current. Let's find out. If I'm gonna try to search and find the current only for R1, I'm gonna call this IR1. I can say, okay, I is still gonna be V over R, but in this case, I'm just gonna use R1. So V over R1 will be 12 volt. So I'm actually assuming that they all have the same voltage to find out whether this is true or not. Of course it's true, I wrote it. Well, I didn't find it, I've wrote it because many other people found out, and I've used this before, but anyway. So we're going to have 12 volts over 1, which is just this resistance. So since this resistance is very, very small, all the charges are going to go through, and I'm going to have 12 over 1, which is 12. So 12 ampere. Now, IR2 is going to be V over R2. So this will be 12 over 2. Which will just be 6 ampere. And lastly, we will have IR3, which will just be 12 V over R3, so 12 over 3. So 4. Now, let's see whether this is the same as saying, okay, this is the total current. Well, I will be IR1 plus IR2 plus IR3. So 12 plus 6 plus 4. And well, 6 plus 4 is 10, so 12 plus 10 is effectively 22 amps. So as you can see, we have found out the exact same amperage that we had before when we calculated the total resistance of 0.54 ohm. So as you can see, in parallel, they're all gonna have the same voltage, but the current flowing through them is gonna be different. It's gonna be 12 amps here, 6 amps here, and 4 amps here.